All right, so for this one, the question is, what is the gravitational force? Let me put my face over here. Between a person that's 55 kilograms, so the mass of this person, we'll say mass, lowercase p for person, is 55 kilograms. Okay, and then the couch is. Do they tell us the couch? Yeah, it's 140 kilograms. So we're going to say the mass of the couch is 140 kilograms. And the distance between them is from here to here. And we'll call it, and when we think in terms of gravitational force, you think of it as like a circle. So it's technically the radius. So the radius of this is 0.68 meters. All right. And so one of the things, and I noticed this on the last test that I gave you guys, remember everything has to be converted to radians, everything has to be meters, and the mass has to be kilograms. So a lot of people got a couple of questions wrong, like one or two, because they didn't convert it to meters. There was one about Earth and the satellite and the kilometers, and they didn't convert the kilometers to meters. So they had the right number. They were just off by a magnitude, 3 orders of magnitude. So it was a smaller number than it was supposed to be. So then what's the formula for all this stuff? Well, remember that the force due to gravity is equal to the gravitational constant G. Remember that capital G is equal to 6.67 times 10 to the negative 11, and there's a bunch of units. It's like Newton meters. Well, I'll just write it down. Newton meters squared per kilogram squared. Okay. And then you have the mass of the first object, which we'll call MP, and then the mass of the second object, which we'll call MC, all over the distance between squared. So when we plug that in, I'm going to get 6.67 times 10 to the negative 11. Okay. I might have to zoom out a little bit, I think. Times 55 times 140. Right? The mass of the person is 55 kilograms. The mass of the couch is 140. Divided by 0.68 squared. Now you can actually do this in Desmos with the scientific calculator. So I'm going to say 6.67 times 10 to the, raise it here by hitting this button, negative 11. Then I got to use this right arrow to get out of that superscript. And then I'm going to hit this button right here, which is my fraction. Okay. And then I'm going to say 55 times 140. And then on the bottom, I'm going to say 0.68 and then square it. And so when I do all that stuff, when I hit enter, that's the answer I get. 1.11 times 10 to the negative 6. That's actually the answer. So the final answer is the gravitational force between the two of them is about 1.11, bless you, times 10 to the negative 6 newtons. Now that's a very small number. That means it's a decimal with 5 zeros and then 111. So that's much smaller than Earth's gravitational force. If you take a person and this person and this couch and you put them up in space, eventually they'll start to drift towards each other. But because we're on Earth, Earth pulls the couch and the person down towards the center of the Earth. It's much stronger than 1.11 times 10 to the negative 6. So we're kind of stuck. All right. So when you go home tonight, don't stand in your living room waiting for the couch to pull you in. It's not going to happen. Okay. And I got one laugh. It's early in the morning.